Alright, hello everyone, and welcome back to Haitu Tutoring. Today we're going to be talking about geometry and specifically measuring angles and arcs. So let's start with some review. So the first thing we're going to be talking about is what are congruent angles. So congruent angles are just two angles that have the same length, or rather the same angle. So if we had three little chords right here, three little line segments, and then if the angles of both of these were the same, let's just say 20 degrees, then these would be congruent angles. Another form is right angles, where if we had another circle and then we had these two line segments, since this line segment is perpendicular to mean, or at 90 degrees, these two line segments would form a right angle, which is then 90 degrees. So the third one is linear pairs. So let's see what that looks like. If you have yet another circle, and then if we draw a line somewhat like this, we're gonna have this angle and this angle. Now both of these angles are gonna add up to 180 degrees. The reason for this is because the initial line is straight from here to here. Let's call that point A to point B. It's a straight line, so that means the angles in between these two will always be 180 degrees. Then let's get into some new stuff now. So let's talk about central angles. Alright, central angles are basically angles that are intercenter. I mean, it's pretty self-explanatory. But let's just draw another right angle real quick. Let's call it A, B, and C, these 3 points. The angle, this is a notation, A, B, C, will be a central angle because the vertex is in the center. So one thing to remember with central angles is that the vertex is always going to be in the center. Right? And now let's talk about arcs within central angles. So let's just start off with arcs. If we draw the same example again, right, we have the angle, but then we also have this arc between A and C. We're gonna call this arc A and C. This is notation. Is gonna be equal to the angle of ABC. Now the reason for this is because it's a central angle, so the arc will always be equal to the angle if it's a central angle. So the value will be the same. I hope you can see that. Yeah. Okay. So let's do a little practice. Alright, so right now I'm just drawing a triangle. Or not a triangle, but rather a circle. And can you guys find me the angle of arc KL and measure of arc MN. Alright, so hopefully you've done some practice. So the answer will just be, for KL will be 60 degrees, and for MN it will be 55 degrees. Since the vertex of both angles is at the center, that means the angle, which is 55 degrees, is going to be equal to arc. So in KL, this is the arc, this is the angle, they're both equal to each other. For MN, the same thing. Okay. Let's move on to inscribed angles. So what are inscribed angles? Well, essentially they are angles where this vertex is not in the center. So I'm just going to be drawing visuals. I'm not going to be writing notes today. I think visuals might be a bit better to visualize. So as you can see, this is a vertex, by the way. Vertex. This is at the circumference or the outermost point of the arc, right? So that is basically what an inscribed angle is. And then an intercepted arc is the arc formed by the inscribed angle. So this is the inscribed angle. And then this right here, this little region, is the arc which is formed by the inscribed angle, known as the intercepted arc. So the rule for intercepted arcs is that the measure of the arc, or sorry, the measure of the angle is always the half the measure of the arc. So let's do some practice on that real quick. So let's just say that this arc right here is 90 degrees. Okay, so let's call this A, B, C. So arc BC, because we're always going to use the outer, is 90 degrees. Now in an inscribed angle, the angle is going to be half. So angle of ABC is going to be 1/2 times arc BC. Now we know arc BC is 90, so we can just say angle ABC is 1/2 of 90 degrees, which is 45 degrees. So then angle ABC is 45 degrees. So essentially the main takeaway is that the arc will always be twice as much as the angle in an inscribed, whenever the vertex is in on the outermost edge of the circle. Alright, let's move on. So now let's talk about one last angle relationship for today. We have angles with the vertex inside of the circle. So if we have this circle right here, and then we draw this, so it all makes sense in a minute. Okay, so we have a theorem which states that the angle of DEC, this is DE by the way, sorry, the angle of DEC is gonna be equal to, so measure of the arc of DC, measure the arc of AB divided by 2. So this angle right here is gonna be the big angle plus the little angle divided by 2. The way that I like to simplify this formula is by saying big angle is equal to big arc plus little arc divided by 2. That's just the way that I think of it. So for example, let's just say this big arc is equal to, let's just say 70 degrees, and the little arc is 20 degrees. If we're trying to find the angle of DEC, which is this right here, we can just do 70, which is the big arc, plus 20 degrees divided by 2, which then is going to get us 90 divided by 2, which is 45 degrees. So I'm going to leave you guys with one little practice. So let's say we have this circle, and then something like this. And let's say this is 60 degrees, the arc. And this is 20 degrees. Alright. So find me the angle of AEB. Okay? Based off of these parameters. Or rather the angle of DEC. I apologize. Find me the angle of DEC. Alright, so hopefully you've done the practice. So it's gonna be big arc, which is 60 degrees, plus the little arc, which is 20 degrees, divided by 2, which is just gonna be 40 degrees. And that's it for today. Thank you very much for watching. Yeah, thank you.